So the next scientist now that we need to what to check is what is de Broglie. The what? De Broglie. Look at de Broglie. De Broglie discovered the wave particle duality of an electron. Wave what? Particle duality of an electron. See, this man, de Broglie, he tells us that what? Yeah, be what? His own contribution is what is 1924. Let's not forget. 19 what? 24. The de Broglie tells us what the electron have behave like a wave and as well as what? As particle. That is what de Broglie hypothesis of an atom. But electron is a wave and it's also a what? A particle. Because the electron have what? A wave property and it's also have what? A particle property. What are the what? The wave properties of what? Of an electron. Mm-hmm. Yes. De Broglie, Abi? What? De Broglie, I said it discovered what? Wave what? Wave particle of what? Of an electron. His own discovery is what? Wave power what? Particle of an electron. That is what de Broglie contribution of an atom. He said electron is a wave and it's also a what? A particle. Why is it that electron is a wave? He said electron is a what? A wave because the electron can what? Undergo reflection. The electron undergo refraction. Electron undergo polarization. And in short, electron undergo what? The wave properties. That is why electron is a what? Is a wave. And it also wants to say what? Electron is a what? Particle. But because electron undergo what? Photoelectric effect. Photoelectric what? Effect. So electron also undergo what we call what? Compton effect. Compton what? Effect. Another electron also undergo what we call what? Brownian what? Motion. So for the electron to have both wave and particle property, what the Broglie said what electron explained what the wave particle duality of what electron. So what electron is a wave and it's also a what a particle. And take for instance now, for electron under the Broglie, for wave property of an electron, wave property of what of an electron, according to the what Nibor quanta, the energy of an electron is hf. This is quantum energy. This is what Planck what constant. This is what frequency. So from here now, we can say that what you know, electron is a wave. We have what the speed of light is what f lambda. This is the speed of light. Frequency times what lambda. From this expression, our frequency equal to the what c over what lambda. Have you now? So we can now substitute for what by taking this for frequency here. What happened? The energy E equal to the what h. What is f? C over what over lambda. This is what equation what 1. I'm talking of what of the what de Broglie wave particle duality of what of an electron discovered by what by de Broglie. This is the wave properties. This is the particle property, but mathematically, the wave properties of an electron is known as what? As this change in E, h c over what? Over lambda. And you can also get for what? For particle properties of what? Of electron. So that is what? About Einstein mass energy relation. We say that what? E equal to the what? Change in mass c square. Good. So this one is the what? Equation what? 2. Equation 1 is what? The wave properties of what? Of an electron. Equation 2 is the particle properties of electron. By equate the two together, what are you going to have? We have what? We have change in what? E should be equal to the what? Change in E. Oh yeah, we now have what? Hc over what? Lambda for this one. This we have change in M over c square. C cancel one c here. We have h over lambda equal to the what? MC. Abi, make another sort of the formula. We have lambda should be h over what? MC. This MC is named as what? Momentum, which is P. So this is lambda. This lambda we call it what? The what? De Broglie wave length. So this P is what? The P there represents what? Momentum. And momentum is mass times velocity. That's what we have here. This H is constant, it's Planck what? Planck constant. So this is what we call what? De Broglie what? Wavelength. So back to the what? To the atomic discoverer. The De Broglie discovered the wave particle duality of what? Of an electron. The next person is what? Is Ijmbe. Ijmbe. This man, his own contribution is what? He discovered the uncertainty principle. Principle of an electron. What is the contribution of what? Of Ijmbe? Ijmbe is the scientist that discovered uncertainty principle of what? Of an electron. We said that is what? It is impossible to measure both position and momentum of an electron simultaneously. Ijmbe said that what? We can never determine or measure the position of an electron and the what? Momentum of what? Of an electron simultaneously. Let's check the Ijmbe contribution. So this man said that what? We cannot what? Determine the position. This position change in what? S. And what? Momentum. What is momentum? Change in P of an electron simultaneously. So this is what Ijmbe what? Expression. The position and momentum of an electron, we cannot determine them what? Simultaneously. Or we can also say that what? This change in X, this is what? Mass times what? Velocity. Abi now, this equal to the what? 2 pi. Take this M here. You have change in what? X. Change this. This 2 over what? 2 pi M. You can also say that what? The Ijmbe principle states that it is impossible to measure what? Both position and the velocity of what? An electron simultaneously. We can also use it in terms of what? In terms of energy and what? And time. So just have it at the back of your mind that what? The Ijmbe discovered uncertainty principle of what? Of an electron. The uncertainty principle of an electron discovered by what? By Ijmbe. The de Broglie discovered what? Wave particle duality of an electron. We have Nibor discovered the energy quantization of what? Of an electron. And it's also have what? Nibor what? Nibor model. The Nibor is also what I explained the one electron system of hydrogen spectrum. The what? Nibor. The James Chadwick discovered what we call what? Neutron, while Goldstein discovered proton. Michael Faraday electrical behavior of what? Of an atom. The Moseley discovered atomic number. R.A. Millikan discovered the charge of an electron as well as what? As the mass of what? Of an electron. And Ernest Rutherford discovered what we call what? The positive central nucleus of what? Of an atom by using what? Scattered experiment. J.J. Thomson discovered the electron and a charge to what? To mass ratio, where John Dalton discovered atomic theory, but Democritus is the one that introduced atom to us in the 400 years before Christ. So the next scientist now that we need to talk about is what? Let us look at what? Ijmbe. Ijmbe. Ijmbe discovered radioactivities, but but it was later named by Curie, by what? By Marie Curie. It was later named by what? By Marie Curie. The radioactivities were discovered by what? By Ijmbe, but it was later named by what? Marie Curie. Next, what? Scientist, which is also the what? The last scientist for this historical development of what? Of an atom. His name is Schrodinger. Schrodinger. This Schrodinger introduced wave mechanics to us. Introduced what? The wave what? Mechanics to us. And the Schrodinger discovered the wave equation of an electron, which is also known as what? The Schrodinger equation. So that is all about what? Historical development of what? Of an atom. But in summary, once again, an atom is the smallest particle of an element which take part in chemical reaction. What? Atom comprised of what? Of two things: positive central nucleus and negatively charged what? Electron, which orbit the what? The nucleus. Inside the nucleus of an atom, there is a two particle there called proton, which is positive charge, and electron, which is neutral. So I said the electron in the what? In the atom, its own function is what? To participate in what? In a chemical bonding or in a chemical reaction. This nucleus combined of proton and neutron, as the function of proton in an atom is what? Is determine the atomic number. Where the what? The neutron is what? Is determine the mass number of what? Of an atom. And from there, we talk about what? The historical development of what? Of an atom. I said atom was discovered by a Greek philosopher. His name is what? Is Democritus in the 400 years before Christ. It is the man that is what? That tell us that what? The smallest particle of an element is called atomos. It is atom. And after Democritus, another person came. His name is what? J.J. No. His name is what? Is John Dalton. Dalton is the one that is big what? The atomic theory for us. He said that what? Atom is the smallest particle. Atom neither be created nor destroyed. Atom of two or more elements, of atom of the same element, are look alike in all aspects. It's also what? Atom of different elements, they are not look alike. And it's all said that what? Atom, they combine with each other in simple ratio. Abi? But if you now look at what? The Thomson, the Darting atomic theory, I said the theory is what is not valid anymore. So we now have what modern atomic what theory, which encountered the what the Darting old theory. Look at the Darting the first theory. He said that what atom is a smallest particle of an element. If it is smallest, after atom there's nothing again. But furthermore, when the Rutherford came, J.J. Thomson came, and Gostin and James Chadwick, they tell us that what inside the atom we still have three particles inside it. Some they tell us that what we have what electron. Rutherford tell us that what we have what nucleus. Where was James Chadwick tell us that what we have proton inside the what the nucleus, and Gostin tell us that what Gostin tell us we have proton inside the nucleus, and James Chadwick tell us that we have neutron inside the what inside the nucleus. And they said what atom is what is smallest particle, and they still have what proton, neutron, and what electron. Therefore, the theory, atomic theory by Darting, we say that atom is the smallest particle is what is not exist. Atom is not a smallest particle because inside it we also have three subatomic particles. And again, this same atom, the Darting said atom cannot be created, we cannot destroy atom. But I said Ijmbe discovered radioactivities, Marie Curie later what name it. If you remember that what in nuclear what fusion, if you have uranium, if you bombard uranium with what with neutron, it will what change to the what we call what barium plus what tritium plus large amount of what of energy. So we can what we can break uranium to the barium and tritium, and the process is called what nuclear fission. We break, abi, and we also have what we according to the what to the Darting theory. You know the Darting theory, he said what atom can either be created or not destroyed, abi. So nuclear fission destroy what disqualify it, abi, and we can destroy atom, we can also what make atom by nuclear fission. Take for example, if you have what hydrogen 1 plus tritium 1 3, come together they can give us what helium 2 4. This is what we call what nuclear fusion. So the second Darting theory is also what countered, and the next one said what is an atom of the same element, they look alike, abi. But I now said in the case of what of hydrogen 1 hydrogen 1 2, and hydrogen 1 what 3. So this one is called what protium, this one is called deuterium, this one is called what tritium. They are element of what of hydrogen 1 but their mass number are what are different. So atom of the same element, they are not look alike in case of what of isotope. So the third Darting theory is also what counter, is also what nullified. The fourth one say that what atom of different elements, they are not look alike, but in the case of what of isobar, isobar, we have what carbon 614 and nitrogen 714. They are atom of the what of different elements, but they have the same mass now bar, and so on. So the next person is what is Thomson. Thomson discovered what electron and charge to mass ratio, and it's also what atomic model called Plum-Ponding model. Followed by what Rutherford. Rutherford discovered what the nucleus of an atom, and by what alpha scattered experiment. And the Rutherford also have what his own model called planetary model. And the next thing is the what Robert Millikan discovered charge of an electron and the mass of what of an electron by odd drop experiment. The Moseley discovered atomic number, and the Michael Faraday discovered electrical behavior of an atom. Goldstein discovered proton. J. Chadwick discovered neutron. Nibor discovered energy quantization, and it's also discovered the hydrogen spectrum. and it's also have its own what? Its own model. Then the next one we have the Broglie hypothesis, which explain the what? Or the Broglie discover the wave particle duality of what? Of an electron, and it also have its what? Its own wave what? Wavelength. And the next man is what? We have Ijmbe uncertainty. It said that what? The position and the momentum of an electron cannot be determined simultaneously, or the position and the speed cannot be determined what? Simultaneously. Then the next one we have what? Score what? We have Ijmbe who discovered radioactivity, and followed by what? Schrödinger, who discovered the what? The wave particle duality. That is all about what? Historical development of what? Of atom.